Here we go. In this video, we're gonna learn about count inversions. So you have given an array. We need to find out inversions count. So if we have element I and element j, element I should be greater than element j, but its index should be less than. So inversion count for an array, inversion count indicates how far the array is from being sorted. If the array is already sorted, then the count in inversions is 0. If an array is sorted in reverse order, then the inversion count is the maximum. So in this test case, this is our input array, and here 2 is greater than 1, 4 is greater than 1, then 4 is greater than 3. So we have 3 inversions. In this case, we don't have any inversion. In this case, we don't have any inversion. So let's take this test case. So 2, 4, 1, then 3, 5. So we need to check, we need to find out how many elements are there. So ith I should be greater than ith j, but I should be less than j. So we gonna apply merge sort here. So merge sort, so we will first divide it into two portions. So we have this and this portion, then we further divide into two portions, to this portion and this portion, then it will further divide it this portion and this portion, but this has only single element, so we just return back. Then what it's time to merge. We have this element and this element. So what I will do is, so let's say I have some elements here. So we have to uh, believe that at this stage, at any stage, this is already sorted and this is already sorted, then only we are merging it. So how do we merge it? So let's say we have this array 1, 2, 4, and we have 1, 3, 5. So our ith element here, jth element here, we need to check ith element should be greater than jth element. So is this element greater? No, this element is not greater. So what I will do, I will just increment my I pointer. Now is the element greater? Yes. How many elements are greater? This element is greater. So let's find out for next element. No, this element is not greater. So we only got one element. This is our one indexing. So I will just pick j. So it will tell us how many elements are greater. Then for this particular element, we found one pair, 2 and 3, 2 and 2 and 1, 2 and 1. This is our first inversion. Then I will increment my I. So for this particular I have to check how many inversions are there. So till j minus 1 we are good. Now we are checking for jth element. Is the jth element smaller? Means our ith element greater. Yes, our ith element greater. So let's find out for more elements. So I will increment my j. Then is this current element greater? No, this current element is not greater. So it is at index 2. It means we got two elements. So it means 4 and 0, then 4 and 3. So we got three elements. Now let's find out for next element. I will increment my I, but there are no such elements, so it will just break out. And for this array we got three inversions, three count. So let's find out for our input test case. What we got? We have this element and this element. So 2, 4, I is here, then we got 1, our j is here. So for this particular element, how many elements are there? This element is smaller, so we are good. So we need to check for next element. So then j goes out of bound. It is at index 1, means for this particular element we only got one element. So we got 1 from this. Then let's check out for this element. So for this element, j is still here, so we will not increment our j because it is already out of bound. So for this particular array, we got two inversions. So then we will just merge it and return it. We will merge these two array, and this will return, and we merge it. So after merging, we got 1, 2 and 4. So 1, 2 and 4. So it's time to break out this array. So how many inversions are there? So 3 here, 4 here. It's time to merge it. So I here, j here. For this particular I, how many inversions are there? Nothing. No inversions are there. So let's check out for next element. I will increment my I, but now my I is out of bound. So there are no such elements to compare. So just return. It will return me 0. So these two arrays return me 0. And we go to sorted array. So it's time to find out from these two sub arrays. So we go to this and this. Our I is here, our j is here. How many inversions are there? Is our I greater than this? No. We need to check out for next element. There are no such inversions for this element. How many inversions are there for this element? Is our ith element greater? No, our ith element is not greater. So let's check out for next. So then, is our ith element greater? Yes, our ith element is greater. So this is one inversion. Let's check out for more inversions. So is this element also greater? No, this element is not greater. We only got one inversion, 4 and 3. 4 and 3. So 4 is on the left side, 4 is on the left side, and 3 is on the right side. So it will give me one inversion. This particular subarray, the merging will give me 1. So we got one more, and it will return me a sorted array. So we got what we got 1, 2, 3, 4, 5. So we are getting 1, we are getting 2. So at the end we got 3. So that's how this will work, and we just need to apply merge sort. Simply merge sort will work. So it's time to code it. So we got n, then we have merge sort. We have merge sort L and R. I am passing L and R. So why, if this condition holds, just return it, find the middle element, then recursively call the same function merge sort. It's time to merge it. So we got merge. We have L, mid, and R. So it's time to find out the length. So we got n is this, and our m is the length of right subarray. So it's time to find out. First fill the left and right. So we just initialized and it's time to filling. So we filled our left array, we filled our right array. So mid plus 1 for the right subarray, and L is our starting point for the left subarray. I hope you are already familiar with the merge sort. So this is the count inversion step. So we start from 0, then j is also start from 0. So we have this. So if this condition holds, our left, so that's what we want, our left should be greater than right. If this condition hold, we need to count more such subarray. So we just need to increment our j pointer. So it will point to the counts. So this is zero based indexing. So we just get the j. So j will tell us how many inversions are there. So now it's time for comparison and merge the array. So we have L, we have A. So we are filling our A according to L, according to left, and R means right. So we are comparing and filling our array in ascending order. So if no such comparison exists, so if I still less than n, fill left array, fill from the left array. If j still less than m, fill from the right array. At the end, just return your answer. Now it's time to run this program. So it's time to calculate the time and space complexity. So before that, let me connect to the internet. Now let's give it a run, and now let's talk about time and space complexity. As we have merge sort, so it will take n log n, and for space we have this left and right. So space, you can see order of n. So that's all what we got. So now let's check out. So we have made expected time and space complexity. Code is given in the description box. Thank you all for watching.